So, very good morning to all of you. So, I hope I have introduced myself to you long time back, but again I will introduce. So, this is Raj Kumar Arya, Associate Professor in Department of Chemical Engineering, MIT Jalandhar. So, I would be teaching you this fluid mechanics. As far as my introduction is concerned, I did B.Tech from HBTIK Kanpur in 2001, Masters from IIT Delhi in 2002, Ph.D. from IIT Bombay in 2010. After that, I worked in BITS Planning Goa campus for a period of 1 year. Then JP University, Guna, Madhya Pradesh for a period of 4 years. Then Thapar University, Patiala for a period of 4 years. So I'm here in NIT Jalandhar since last 2 years. So I would be teaching you this fluid mechanics course. And syllabus, we can discuss about the syllabus. I have already shared you with the syllabus actually. So you have three lecture in that, one tutorial, one and practically you have practical, but practical here is the separate course code actually. So here in this slide you have mentioned zero practical because practical will not be included in this particular course code. That is the different course code, right? So three lecture, one tutorial. So as far as this exclusively for till the period of online classes, we may have a exclusive tutorial also someday, but sometime it would be lectures only because wherever the problem would come, we will solve the problem in the class time only. So I don't leave the things that teach the theory now and solve the problem after 8 days. So by that time, everybody forget the thing actually. So I don't like that policy. There would be tutorials just to clarify the doubts and all this, but you can ask your doubt as many doubts as you have during the class also. I don't mind. And practically, I would be happy that if you will ask doubts during the class because it will clarify you very well in that particular time. You can type also, but I will say without typing because I am connected with two things. One is mobile, one is the laptop. So typing question and doubts is not good idea. So better you can say that you have this doubt and that doubt, right? So that is one thing. So here in this case, I can tell you first is that that is the most important part is your actually evaluation the scheme. Actually, I want to clarify it first. All internal marks would be decided based on your surprise quizzes only. These would be one or two per topic. Okay. Minor one, minor two would be as per the institute guidelines as they will issue the guidelines and semester also as per the guidelines. But internal marks would be based on your surprise quizzes. Some assignment can be given, but most of the time experience of the assignment was not good due to copying and all this. So I don't prefer them much actually. So your surprise quizzes, you should be attentive in that. Whatever being taught in class, same time you may be asked to solve a question actually. So all the time you should have your calculator and pen with you actually. It's not like that the listening the lecture every day and just getting over. It's not that way. In the meantime, when you have theory, you have questions, so you have to solve that particular time. Fine. So we can come back to the syllabus part. So first part is introductions because fluid is nothing new to you. Actually, everybody is dealing the fluid in somewhat different way. So most example is water. You have so first thing you go your washing machine or sink. You have a water tap there. So that tap is called one sort of valve, right? That in fluid mechanics term you call that faucet. So that have a knob that is valve, right? So that valve control the flow. So if that fails, so you have to control the flow with the help of valve. So valve is the part of also the fluid mechanics. how much flow you want, so you have to change that knob according to your convenience. So that is one thing. Then you need something, sometimes you have to measure that how much volume is coming, something and all that. So in that way, you have to measure its quantity, how much quantity is flowing out per unit time or per unit time practically. It could be minute, second or hour. So that is, so first part is introduction. So introduction means for introduction you have ideal and real fluid, and then you have non-ideal fluids. So ideal fluid means ideal, you can understand very well that ideal gas law thing, so you can something correlate from that. So ideal means something which have its unique properties, those are not getting changed by changing the slight temperature and pressure conditions, right? That's called ideal fluids. So ideal means its properties are not getting changed. So in case of fluid, your properties are density, you have viscosity, you have surface tension. So these are the things which are most important for fluid flow. Then in case of heat transfer, if you would talk that for fluid, you need heat capacity also, correct? So then you have its properties, extensive and intensive properties. So extensive properties are the properties which depends on your, you can say, is quantity actually. So let's say your mass. So mass is extensive quantity, means the quantity or intensive quantity. Can anyone tell?
Extensive
Intensive.
quantity.
Yeah, mass is extensive. Yeah, because you take the this much quantity or that much. So in that way, you can actually you can have more and more. Intensive means are the independent of quantity actually that will not change. So the whatever quantity you have per unit mass basis or let's say per unit volume basis, those never change no matter how much quantity you have. Just like your density, your viscosity, your surface tension, your heat capacity. These are per unit mass quantity actually or per unit volume. So those will not change, right? Then you have specific weight. So specific weight is the nothing, just density multiplied by G is called a specific weight actually. Or you can say weight per unit mass is called the specific weight only, right? Then you have mass density. Mass density is the simple, the density which you talk about actually. Specific gravity, you already know that 1 by of rho is called the specific the gravity. Means the reverse of density is called the specific gravity only. Then you have viscosity, surface tension, and capillary rise. So this capillary thing means you might have heard first time I think in your 12th standard or these days you might have in 10th also where you have small pores and all this. So liquid either goes up or goes down, right? So that is called capillary action actually. So that also is the important in case of fluid mechanics, just like your petroleum oil or let's say the something you are drilling from very downstairs or sometimes you don't want to put a pump and all this. So somehow you can make the arrangement of capillary. So sufficient means quantity of the fluid can be then lifted up. Now this most probably people follow in geothermal engineering actually. Then you have evaporation and vapor pressures and all this. So evaporative property and vapor pressure is just a pressure only. So you have pressure correlations from thermodynamics. Newtonian and non-Newtonian fluid. Newtonian fluid is called ideal fluids, whose properties are not time dependent actually. Non-Newtonian means are the fluids which vary with respect to time. Means just like your paint or let's say your toothpaste. So in case your toothpaste you will want to press it, nothing would come out. You press it more, further the nothing would come out, and the time you will press it again more, then it will continuously coming out from the tube, right? So that is non-ideal fluid. So it need a minimum force to make it flow. Below that it won't flow, and beyond that it will flow at a constant speed, right? Just like a paste, the same quantity will come whether you press it by thousands of a Newton force or let's say hundreds of a Newton force. If it is the minimum force for that is 50, beyond that, you can put as much force as you can, but whatever quantity is coming from the tube, that will not change, right? Only speed may change. So those comes in the category of non-Newtonian fluid, just like your paint also. So paint, if you want to circulate in the beginning, so that paint will be hard in the beginning. After that, once you move it continuously for a long time, it will become easy to move it, right? So that's called shear thinning fluid. Primarily, it was a thick fluid, and later on, the time you have moved it continuously for a long time, its viscosity decreased. जिसको बीच में कुछ पूछना है, they can ask, right? Okay. So that is called the introduction of fluid mechanics. What fluid is, various properties, or something. Next topic, you have fluid statics. So fluid statics is here you might have done the in your 10th or 12th some Pascal's law, right? Hello? Have you heard Pascal's law?
Yes, sir.
So,
Yeah.
yes, sir.
So that is fluid statics actually. So is nothing but you have filled a fluid in some container or in the reservoir. Statics means fluid is at rest. So fill it in some container, something. Container could be your bucket, your could be a large container, your could be a reactor, your could be a pressure vessel, your distillation column, or just like your overhead water tank which you have in front of your hostel, right? Let's just say fluid is at the static. You have filled it once. Now you want to analyze it. What will happen to that particular fluid? How much pressure would it create on the walls of the container? How much pressure would it create at bottom of the container? And what should be the flow would come out from there? Because more you will have height, more you will get the velocity out, the discharge velocity, right? Because in that way your potential energy is getting converted to the kinetic energy, therefore velocity is more in case of more height of the fluid. So as you will put your overhead water tank on top of the roof, your velocity would be high. If you put a ground floor, your velocity would be low because your potential head is low. So in this particular chapter, you have pressure. Hydrostatic laws means how the pressure would change with respect to height actually. Pascal's law, you already know that pressure works in all directions equivalent. Is not a function of direction, right? So it is the actually the scalar quantity only, it works in every side in a particular plane. So if you are at this plane, it will have same pressure throughout. If you move it, pressure would be different. But if you move in this horizontal side, there would be no change in pressure. Then you have how to measure the pressure. So manometer you might have heard actually. So manometer is just a U tube actually. So you tube the device you connected to two end of the fluid actually you will get the difference in the limbs, and that the difference would be your pressure actually. Then decanter means you have filled a tank. Now you want to make a hole into that so that you want to take out the water from that, water or fluids. So that's just called gravity. The decanter means you are not putting any pump to drain the fluid from the tank. You are just putting a hole. Now hole can be rectangular, it can be square, it can be a V shape, it can be a half semicircle, right? So depending on type of that, you can calculate how much would be the discharge point. Then you have centrifugal, the decanter, pressure measuring in the equipment, and something is called metacentric height. So this is just to measure your stability of the floating body. So the time you will put the something on the fluid, either it may sink or it may float or it may submerge. There are three things. float, submerge, and sink. So if you want to design something like a ship, something, so it should be float with some submerged part. So you have a metacentric height. The stability is part so that in case of slight tilt in waves of the sea, your boat or ship should not topple down, right? So that is one thing. Second part is that you want sometimes you want things to be submerged. Submerged means it should completely in the level of the fluid on top surface. So that can only be possible if the density of two systems are same. If your density or water density both are same, you would be floating on the top surface only, completely leveled, right? If your density is too much high, so you are going to sink. So to decrease the density, what you have, you can increase your volume. So that's where you design your floating body systems. So these are the topic would be covered in your statics part. Then you have kinematics, and this kinematics means now you want to move the fluid. Actually, previously you talked about statics. The fluid is completely at rest in some container. Now you want to move it because it's not the purpose just to hold the fluid. Because in chemical engineering or all means the engineering, first you have a feedstock. Feedstock is completely called statics part. After that, you want a transportation part. So transportation means you have to move somehow. You have to give some velocity. You have to give some movement. Then you have dynamics. So once is the velocity, then you want to put a force in that particular part. Force could be unsteady, steady, and all this. So finally, this will give a velocity component and then acceleration part. So total would be covered in the topic of fluid kinematics and this dynamics part here. So in this here, you have the Renault transport theorem. So this will explain how this fluid would move from the system property to the control volume part. So you might have heard something, a system. System means just like a mobile, if you see it, the total of the mobile, if you can encircle the outer boundaries by a thin film on that, this will become a system, right? Now it have a volume. So now if you are focusing on its volume, so volume would be the different property. System is this the mobile. Now you have control the surface. The wherever you can touch the system is called control surface. Fine. So this is the one thing called surface. Now after that, from some of the points, some quantity can it can come in, some quantity can go out actually. So that's called your control surface. Just like a tank which is filled completely, now it is closed. It have the surface, but it doesn't have a control surface. Why control surface? Because nothing is coming out, nothing is going out. It is completely filled. Now, suppose you have made a hole, just a fluid to come out. So you have one control surface from where the fluid is going out. You can put the another pipe connection in, so that would be the another surface from where the fluid is coming. So from where the fluid or mass can either come in or can go out would be treated as a control surface. Fine. Then you have classification of fluid flows. So you have to classify the fluid actually unsteady flow, steady flow, one dimensional, two dimensional. Mean that it could be the function of x only, function of y only, function of z only. Then you have these few things, streamline. So streamline, I think you might have heard the something in case of Bernoulli theorem. I think Bernoulli you might have heard in your 12th, but there,
Yes,
Yes,
sir,
sir.
it was there.
so Bernoulli you might have seen that your velocity vector would be always your tangential to the direction of the flow of the fluid, right? So that's called a streamline. Then you have streak line. So a streak line uh, here means a particle has moved actually. So you are focusing on a particular cross section there, and now from there number of particles are passing out. So you may say, let's say 10 particle has been passed out from that particular cross section. Now you want to trace them at a particular time. So you just join the dots where those particles are. That's called a streak line. Then next thing is path line. Path means just like your path, mean the let's say you are in B.Tech first year and now you have to read the final year. So your path is first you will read to first year, first semester, then second semester, then third, then fourth, and fifth. So this is your path. Your path would be the different than other branch people only. So each individual particle would have the unique path. So just focus on a particular particle, where does it move, and just trace it with respect to time. That's it treated as a path line actually. Then you have flow rate. So flow rate is the nothing but is the volume per unit time actually. Then you have continuity equation. Continuity means that mass is a conserved quantity. So whatever mass has been entered to one of the end of the particular vessel or container, same thing has to go out, right? So mass is conserved quantity. So total mass coming in from all control surfaces and going out from all control surfaces must be equal. That is just a conservation of mass only. That's called continuity here in fluid mechanics. Fine. Then you have Bernoulli theorem. So what the Bernoulli theorem says, means any idea for that? Any idea what Bernoulli's theorem says? Can you just recall back?
conservation of energy,
Say it again.
conservation, conservation of energy base.
Yeah, right. So the conservation of the energy. Bernoulli theorem says for the ideal fluid, its energy would remain conserved. So whatever energy it have at one of the end, same energy would be there after 1 kilometer or 2 kilometer or 10 kilometer if it is ideal fluid, right? So ideal fluid, they say the energy will not be lost. Only thing is form will change. Total energy of the particle is, let's say you have a pressure energy, you have kinetic energy, and then you have potential energy. These are the energies you have in a flowing fluid. If you are talking about isothermal fluid, if it is not isothermal, you should have a thermal energy term also, right? So most of the time we say isothermal fluid. So if the temperature is constant, it means no thermal energy term. So you have only pressure energy, you have kinetic energy only because of velocity term, and potential energy only because of change in elevation part actually. So you have these three energies of a flowing fluid, and these should remain constant from one end to another end if it is ideal fluid. So we have the practical for that also to verify it. So whether will it be verified or not. So we have the fluid Bernoulli experiment actually. So today I would show you the lab. We have the lab right at 2:30. Then we have this kinetic energy correction factor. So what do we have? Kinetic energy. Generally, you calculate half mb square, right? Hello. How do you
Yes,
calculate
sir.
kinetic energy? So kinetic energy means you calculate half mb square, right? So in case of fluid actually, so your velocity is not the specific velocity. Let's say you have this much big cross section of the pipe or a diameter. Now at the center it would have the different velocity, at the edges it would have the different velocity, in between of edge to the center it will have the different velocity. So just to calculate the total energy of the fluid, you have to actually, Prabhat, can you mute your mic and all this because the noise is coming? So in that case, your velocity change across the cross section. So you have to calculate the energy. So EGSB is what? Actually somehow you should know is how would you calculate? So if you calculate, let's say the average velocity. So average velocity, practically you have collected this volume in some container, measure the time. So you have calculated particular volume in the container, then measure the time. So volume upon time is the volumetric flow rate divided by the cross section of the container would give you the velocity, right? So that way you will get the average velocity. Now based on that you can calculate your kinetic energy actually, that half mb square. So that is the kinetic energy based on your average velocity because it is the easy to calculate. Now, each time you cannot, but this is not correct because that much velocity is not coming from the pipe. Pipe means center में कुछ और है and at the edges are the different. Now you will put a meter inside that particular tube and you will measure the velocity across the cross section. So you can have infinite the number of the sections there, so you have infinite number of velocities. So each section you calculate half mb square. Then integrate for entire cross section, right? So that would be your actual kinetic energy of the flowing fluid. Fine. So that actual divided by based on your the average velocity would give you your kinetic energy correction factor. Get it? Hello?
Yes, sir.
Did you get it right? So you
Yes,
calculate
sir.
yes, two energies based on the actual that comes from the integral over the cross section. Another one is based on the average velocity because that was the easy to calculate. So you got an integration factor there. So that factor is called kinetic energy correction factor. So each time you need not to integrate it because that is the time consuming the process, and your answers can be calculated based on your average velocity. That is a much more easy and comfortable way, right? So you have their kinetic energy correction factor. Same way you have momentum correction factor. So momentum, mass into velocity is called the momentum, right? Yes or no?
Yes, sir.
Hello?
Yes, sir. Yes, sir.
Mass
Sir.
into
Yes, sir.
velocity is called the momentum, right? So that you might have done the Newton's third law, right? Yeah. There you calculate the applied force and call the rate of change of the momentum. Second law actually is called force.
Yes,
So momentum again can be calculated based on the the average velocity and based on the instantaneous velocity over the cross section. Ratio of the two again would give you the momentum correction factor. Why do we need all these? Because these would be easy to us just to do the further calculation fast, so that we can avoid all times the integration part because integration is time consuming part, and moreover if the we can calculate in the simplest way, right? So these would be used in Bernoulli equations. Next topic is you have laminar viscous flow and flow measurement devices. Means how would you characterize the flow? What type of the flow is? Because you might have heard the so far ideal term, right? Ideal fluid, ideal material, something. So in that case, ideal means its properties should not change. So in case of ideal fluid, actually that's called the laminar fluid, Newtonian fluid actually. So in case of that, we have characterized in number. Okay, how do we quantify it? So in case of the number, we have here the term is called Renault number actually. So this is practically you have there the inertial force upon the viscous force. Inertial force will try to push the fluid. That means the inertia means it will try to rotate the film. Fine? Yes or no?
Yes,
Hello?
sir.
Inertia means it try to rotate the thing. Now, viscosity of the fluid or the rigidity of the fluid, just like in case of the solid material, you have the term the rigidity, right? In case of the fluid, you have viscosity. So rigidity or the viscosity, it doesn't allow to bend or it doesn't allow to rotate. So the ratio of the two is being calculated here now, the Renault number. Now, if this number comes out less than 2100, then it's called actually the laminar fluid. Laminar fluid means जो आपने पहले 12th में पढ़ा है बहुत long time back, streamline flow. So streamline means the flow would be in terms of layers, layer 1, layer 2, layer 2, layer 3, and all layers would be parallel to each other all the time. And these layers does not intersect each other, they always move in a parallel pattern, right? So that's called actually the laminar flow. fluid or the ideal flow actually. If you increase velocity more, what will happen? That pattern will change, right? So that pattern would change, and so once that pattern would change, so once we have more velocity, it will have slightly zigzag, not totally the mean the disturbed, slightly zigzag. So that's called something called transition zone. So that happens between 2100 to 2300. That is the number actually. How do we calculate? We will tell in the course part. Now, if you want to have more force or the disturbance, just rotate something, so you won't find any pattern there. So in that case, that's called the turbulent flow there. So that's what you have here, the laminar flow in the circular pipes. Then you have orifice meters. So orifice is the just a flow meter, just to measure the flow in a pipeline. Density meter also there a flow meter just to mean the measure the flow again in the pipeline. Then you have vias. So vias are two, three types actually. Mean the rectangular vias and V shape or triangular. Vias you might have heard actually in case of bore wells and government bore wells, or you can say canals. Canal, have you ever seen the dam actually? So dam, just to measure the flow rate, you have a rectangular sheet, and on that you have the graduation here, that 2000 meter cube fluid and 3000, 4000 and all. That's a mark on the height. Have you seen that somewhere? Something in the like this?
Yes, sir.
देखा भी है कि नहीं?
Yes, sir.
So you have
Yes,
that
sir.
in actually canals में होता है. The most of the time the canal where the gate is there, where they supply the water to the farmers. So there they have a V-shaped type of thing, and it is marked there 2000, 10,000 LPH liters per hour something, or sometimes the cubic meter per hour. Those are called VS actually. Those are being used to measure the flow rate in the open channels. Then you have the area meter, rotameter actually. So rotameter is again a tapered cross section. So on top it has big cross section, and bottom it has the small, and bottom you have a float. So it works based on the concept of the buoyancy. So more would be force on the bottom, so it will lift up actually. So just like a ball. So you might have seen a kids. You have a plastic का pipe लगा होता है जैसे bucket, and he put a ball here. He just blow the air, so ball goes up, right? So the rotameter also works in that concept. More is the force, more would float will go up. Same thing as the ball concept. More would be the blow of the air. The ball height would decrease or the increase. So you can control it at a particular height by blowing the air only. Same thing here in case of fluid. So you can control the float position by putting more and more velocity. More and more velocity means more is the flow rate. So that's called the area meter, because in that cross section keep on change. So then you have there, then you have local velocity measurement, just like a in that canal thing, or in case of the pipe, you want to calculate what would be the velocity at the center, what would be the velocity at the edges, or let's say 2 centimeter far away from the center. So there's the meter there, pitot tube, which is being used to calculate the velocity at a particular point. So we will see that particular part. Then you have hot wire anemometers. So this is based on the actually the heat capacity concept. So this also gives the flow rate. Then you have mass flow rate meter. It directly calculate your the previous flow meter just give you the volumetric flow rate. Now this flow meter will give you the mass flow rate. So it will somehow the multiply with your volume into density, and then you will finally will be calculating the mass, just like your filling of petrol in just like in a petrol tanks. So petrol tank, do they ask give in mass, or do they give you in terms of volume? पेट्रोल का ट्रांसपोर्टेशन और परचेजिंग would be done in terms of mass or in terms of volume?
Volume.
Yeah, in terms,
Volume.
yeah. So there you need the volume flow meter. Now, what is the quantity which you need in terms of mass? Any quantity which is being sold in terms of mass? Any
Sir,
fluid?
anything which is solid.
Are just give me practical answer.
Sugar.
Sugar is not a fluid actually. Just like your oil actually. So oil you always ask in kg. Hello. Do you ask the oil in kg or do you ask
Liter.
the oil in liter?
Liter.
Liter, sir.
केजी में कौन सा फ्लूइड आता है?
Liter.
गैस इन केजी में आता है. देखो वो ठीक बोला अभी. कौन बोला अभी?
सर मेरे
हाँ
आधा किलो 1 किलो
एलपीजी गैस. या जो एलपीजी गैस जो होता है आपका जो गैस सिलेंडर, दैट्स कॉल्ड बुलेट्स एक्चुअली, गैस बुलेट्स. So in that case, your quantity comes always in kg because you are not interested how much is volume. You are interested there how much kg gas I am getting, right? So there you need a mass flow meter in that case. Most of the places in chemical engineering we use the volumetric flow rate because volumetric multiplied by the density will give the mass. But some quantity need to be sold only in terms of mass, just like your LPG gas cylinder. So there you are the interested into mass measurement, how much mass is being filled in that particular cylinder actually. So this is what just you have so far. You did type of fluids, and then you have the statics part, their motion and velocity part. You did there the measurement. You did how would you measure their transportation in terms of velocity or volumetric flow rate. After that, you need how would I transport? To need a transport, how would I do? Should I carry in bucket and put it one place? Should I transport by means of the tankers? Or should I use the something? So most of the time you follow all of them. We follow all of them. We follow actually the bucket to bucket transportation also in home. We follow the tanker transportation. In case of your petrol, you are transferring the petrol from petroleum depot to the your petrol pumps by means of your tankers only. After that, you have sometimes you have a pipeline. So pipeline is just to you serve where you have a permanent connections where you want to transport. Just like the best pipeline connections you have in your hostel, in your campus, you have an overhead tank. You just load the water once. After that, you turn on the wall. You will get the flow at your home, right? All municipality things you have a piping connections. But sometimes that is not the sufficient. That flow would be at some particular fixed. That means the speed you cannot change because that will change based on the gravimetric height of the tank. Suppose you want to suck the water from the basement, so you need a pump, right? Suction type of thing. So the suction would be created by your pumps. So pump purpose is just to give the additional energy to the fluid to make it flow at a speed which you want. So then you have a pump here. So pumps you have a centrifugal pumps. Centrifugal pumps move in this direction is towards the fluid in the centrifugal action only. Then you have centrifugal pumps. You have completely here. Then you have the reciprocating pump. Then you have piston and plunger type of pump. Piston and plunger type of pump you have in your motorbike. जो बाइक में जो पंप होता है पेट्रोल फ्यूल पंप, it's piston type of thing. So it just put a pump by a force here, so the piston moves up and down, right? So in that case, you need a fixed quantity. So then you have multi-stage pump, just like your very tall building. Each pump have its own capacity, just like each person have its own energy or capacity, right? So it cannot work beyond that. Just like a pump can transport, let's say, fluid up to 100 meter. So after 100 meter, it cannot give the any velocity or the discharge. So at 100 meter, you have to put one more pump, right? So that you can transport it to the further long away distances. Are you getting it or not? Hello?
Yes, sir.
Yes,
Yes,
sir.
sir.
ये
Yes, sir.
पंप कौन से
Yes, sir.
समझ में आ रहा है? तो पंप आर्ट है. Pump means just to give the additional energy, just like a relay race in a game. So there are 4 or 5 participants in that. एक काम करता है, once he get the tired, the next person comes in the queue, right? Then another person comes, then another person comes. So those are called a multi-stage pumps. So you have a pump which will work to a particular height or the in the distance. After that, you need the another pump, another pump. That's called the multi-stage pumps actually. Then you need powers. So how much power would you want to give? So each pump would have a power in terms of your volumetric flow rate. More is the flow rate, more is the power consumed. Fine. So then you have cavitation. So if you don't have anything in your pipeline and if you turn on the pump, your motor will burn. You might have seen it at your home also many times. Yes or no? देखा है कभी घर में कि आपने पंप चला दिया और जल गया पंप? Have you seen that thing? That happens only because of that, because there was no water to suck in the pipeline, and you were turning on the pump. So pump you are giving continuous means the energy to the pump, and pump is not delivering energy to the fluid. So whatever the energy was giving to the pump, it was just being used to raise the temperature of the pump, and finally it burned out. So you should not turn on the pump in the empty. You should have a water there first, so that is to transmit the energy, right? Then you have the lift and all this. So where just like a bore bell. So bore bell, you see the underground water is the 100 meters down. Put let's say Punjab. So water is mean the around 150 down. Each pump can suck the water, let's say from 30 feet. So at each 30 feet, you will have one more pump because the suction lift for that is 30. 30 के नीचे 31 से वो पानी suck नहीं करेगा. So that's called suction lift actually, from where the water can be lifted by the pump. Fine. Suction lift. Then you have the specific speed of the pump and what speed it would work. After that, you have flotation of the body flow around the submerged body here. So submerged body means most of the time you have a pipelines. Your that means the spheres. You want to transport your particles with the help of the fluid. People these days transport, let's say, your coal with the help of the pipeline. So coal, they put a crust particles in the coal in the pipeline and they want to flow it. So that's called flow around the submerged bodies. Flotation or drag. So drag would try to lift the bodies up and it can transport to the transportation part. So these are, you can say, briefly we have the mean the explain or each and every topic. I hope that nothing is very tough in that and nothing is very new. Most of the things you already know. Uh, Book for this course, I will follow this book actually, that this one, the Fox, McDonald Fox actually. This is actually introduction to your fluid mechanics. So this is the main book we will follow. And there are the other books here. These you can means you can get that. This is for the practice point of view. The Munson and the Young, that fundamentals of fluid mechanics. That's also a good book. There's the one more book here, Chemical Engineering Fluid Mechanics by Ron Darby. Actually, that is also good. Actually, this is also there. Fluid Mechanics for Chemical Engineers. Again, the neighbors. And this book you should buy actually. Unit operations for chemical engineering, because this is not only for fluid mechanics. This would serve your three purpose: mechanical operation, your fluid mechanics, your heat transfer, your mass transfer. You will have entire chemical engineering in this particular book. Unit operations by McAvey Smith. So this is the you can say, in short, you can say one of the best book or Bible of the chemical engineering actually. For this course, you can buy this book actually McDonald Fox.
Yes, sir.
Okay, so
Yes, sir.
this is for the today actually.